Hey guys, welcome back to another video. My name is Savannah and I am one of the 4 members of this YouTube channel, and today we're going to be diving into the topic statistics.
Math is so much fun for everyone. Math.
The 4 Mathsketeers.
So if you guys may or may not know, statistics has been a topic that has been discussed previously in IGCSE. But since we are going to be looking into the AS and A level curriculum, we are going to be taking the skills that we have learned in IGCSE and we are going to be making them more suitable and more compatible for AS and A level questions, as they are going to be a little bit more enhanced than the questions that we've had previously. So if you guys have the textbook Math, Probability and Statistics 1, you can see in the table of contents there are going to be 7 chapters discussed in the book, but for the purposes of this video we are only going to be diving into 2 topics, which are probability and random discrete variables. The reason why I've only chosen 2 of these chapters is because they have kind of been touched on a bit in IGCSE, and I think this will be a much easier transition as well. And I think that there's a lot of things that we can learn for probability and random discrete variables. So that's what I'm going to be focusing on today. So before we start this video, I'm also going to put out a disclaimer, I suppose, that all of the content that I'm going to be using today is all sourced from different websites and also different PowerPoints. So if you guys want to use any of the material that I'm going to be using in this video, I'm going to be linking everything down below in the description box. So if you guys want to learn on your own and kind of learn a bit of the material that I've used, maybe you want to do a little bit more review, then you can just click the links in the description box down below and you will be able to get the PowerPoints and everything that I've used for free, and you will be able to download them and use them for your own school time or your own purposes. So for this video today, I am going to just be diving into the topics and giving you a little introduction, a little bit of example works, and at the end of the video, I'm going to be setting out a few questions from past papers that I'm also going to be linking down the description box below that you guys are going to do at the end. So I'm going to give you guys a few minutes to do the questions on your own, and then afterwards we are going to be discussing them together. So you can do this at your own pace, and it really doesn't need to be rushed whatsoever. You can time yourself if you like, or you can just do it at your own pace. But once you're done, you can just continue on to the video, and if you don't understand any of the questions, then you can go back into the video and kind of watch what we have discussed, and maybe you will find out what you haven't been getting throughout the process of doing your questions. So if you guys are still interested in watching this video and diving into these 2 chapters, then just keep watching the video. Right guys, so we're going to jump into probability right away with this PowerPoint presentation. So to start off, probability is used to predict the chance of events happening, and on the screen right now we have 3 keywords that we need to remember throughout this presentation. So first, an experiment is a repeatable process that gives rise to a number of outcomes. This is pretty understandable. Normally experiments can be done, as social experiments or scientific experiments, and it just shows like what can come out of those experiments and what are the chances of it happening. An event is a collection of one or more outcomes, so that's relatively understandable, and a sample of space is the set of all possible outcomes. Very easy, very simple to understand. So now here is a example question. So 2 spinners are numbered 1 to 4, both are spun, and the sum of the numbers x is calculated. Find p, x equals 5, and p, x is less than 5. So right now, I'm going to be showing you guys the table, I suppose, of numbers, and we are going to find the answers. So here you go. Here are the answers on the board. So what this basically means, what are the chances of the number x being equal to 5? So as we can see from the table here, we have 4 times that 5 appears, or 4 times it is possible for 5 to happen and be x equals 5. So what we need to do is, since we have 4 number 5s, we need to write 4 over the total amount of numbers that can basically happen. So we can see in the row here, there are four rows, and then when you have 4 rows, we have 16, because 4 times 4, obviously. So we put 4 over 16, and then we just make that into the smallest number, I suppose, and we make it into 1 over 4. So this basically is the same thing for the second question. P equals x is less than 5. So what this question is basically asking is, when can x be less than 5 during this time when the spinner is being spun? So from the little table here, we can see that there are 6 numbers that are not number 5. They are less than 5, which are the numbers 4, 3, 4, 2, 3, and 4. So because we have 6 numbers which are less than 5, we need to write 6 divided by 16, because we are dividing it by all the numbers that are in the table, and then we get 3 over 8. Very easy, very simple. Just a quick little review. Right guys, so now that we are done with the example questions, we are going to be moving on to just learning about probability. So you need to recognize when events are mutually exclusive or independent. So when 2 events cannot happen at the same time, they are mutually exclusive. This can be written as PA subset B equals 0. So consider the Venn diagram to the right, which let me just show you guys. If the events are mutually exclusive, they cannot both happen at the same time. So they can't be drawn together having a middle where they share the same thing. So PA union B would be P bracket A plus P bracket B. You can also work backwards. If the above is true, then the events are mutually exclusive. As simple as that. When one event happening has no effect on another event happening, they are said to be independent. For example, the probability of event B happening is the same whether or not event A has already happened or not. So this can be said for tossing a coin and rolling a dice. They are independent. For independent events, we have this formula down here. The reverse is also true, so if this rule works, then the events are independent. So at the top left and right corner, there are these formulas that you can just remember throughout the PowerPoint presentation. So events A and B are mutually exclusive, and PA equals 0.2 and PB equals 0.4. So first construct a Venn diagram. If it is mutually exclusive, then the circles have to be separated because the events cannot happen at the same time. So write 0.2 and 0.4 and 0.4 outside. So to calculate, we need to use the formula, the mutually exclusive for mutually exclusive events, which is on the top left corner. So all you need to do is add 0.2 and 0.4, which makes 0.6. If we're only trying to find PA, then obviously it's 0.2, and same goes for B. If you're just looking for PB, then it's 0.4. So if we're trying to find 1 minus P A union B, then it is 1 minus 0.6. 1 meaning whole, and 0.6 comes from adding 4 and 2 together. So it makes 0.4. So events C and D are independent, and PC equals 1/3 and PD equals 1/5. So calculate A, PC subset D. So what we need to do is use the formula on the top right corner, which is PA subset B. So it is PA times PB. So all we need to do is times 1/3 to 1/5. So that makes 1/15. So when we construct the Venn diagram, we have 1/15 in the middle, and we have 1/3 minus 1/15, which is 5/15, minus 1/15, which is 4/15. And all we need to do for D is do the same thing or similar thing, and we have 2/15. And in the outside of the circles, we have 8/15, which is just the remainder of it. So there's that. So for our next question, we have the Venn diagram again. So this Venn diagram shows the number of students in a particular class that watch any of 3 popular TV programs A, B, and C. So first, find the probability that a student watches B or C or both. And B, determine whether watching A and watching B are statistically independent. So from this Venn diagram, when we add up all the numbers together, there are 30 students in total. So 26 of them watch B or C or both, because we all add them together. So 26/30 is 13/15. So all you need to do is just remember the things that we've had in the previous slide, and this will be very simple. All you need to do is separate them from one another, and it'll be a very easy process to just identify what you need in the diagrams. So we are going to be using the formula for independent events for B. So all we need to do is substitute the values that we have, as you can see. And when you calculate them all together, you have 133/900, which you need to convert. So 120 equals 900 equals 133/900. As a rule, for independence does not work, the events are not independent of each other. So it could be that the programs are similar types or are on back to back. So next question. A bag contains 7 green beads and 5 blue beads. A bead is taken at random. The color recorded and the bead is not replaced. A second is then taken and the color recorded. Find P, 1 green and 1 blue. So all we need to do is just make a tree diagram. At least that's what I call it. So first of all, we need to write down the first amount of green balls that we have. So obviously if we add 7 and 5 together, we have 12. So what we need to do for green is we need to write 7/12. And we do the exact same thing for the blue ball. So the second set of probabilities depend on what color was taken the first time. So there will be 11 left and 1 less of either green or blue. So if we're going to go down the green path, then obviously we need to take 1 ball away. So that means that there are going to be less balls in total, and there's going to be a less amount of green balls. So we need to just minus 1 from 7 and 12, and that's how we get 6 and 11. And the same goes for when we're going for blue ball. But since we are not subtracting any of the blue balls, all we need to do is just continue to write 5 blue balls, but we just write 11 instead because we have taken away one other ball. And the same goes for if we do this for blue. It just switches. So as we want one of each, there are 2 possible routes with P one of each, which is this formula over here. So that would mean that 7 over 12 times 5 over 11, since we're getting 1 green ball and 1 blue ball, and that would make 35 over 132. And if we were going to do it for the blue ball, we would just do the same thing. So we would do 5 over 12 times 7 over 11, and we will get 35 over 132. Same thing, same amounts, and all we need to do is just add them together, and we get 70 over 132, which is 35 over 66 each. That will be the probability of getting 1 blue and green ball. Alright, so now we're moving on to statistical distribution. So first we need to understand the use of probability distribution. So we are going to be talking about random variable. A random variable is a variable whose value depends on the outcome of a random event. An example of this can be when we roll 5 dice, the number of 6s rolled would be a random variable. The range of values the random variable can take is called a sample space and is often drawn as a table. A discrete variable can only take certain countable numerical values. So this can be the number of people, has to be a whole number. So as we stated before, we are going to be talking about discrete random variables. So these are values which can only take certain numerical values, each of which can be assigned a probability. This example could be the number of times a 1 is rolled when rolling a dice 10 times. It can only take certain numerical values, and it can each be assigned a probability. So a probability distribution fully describes the probability of any outcome in the sample space. So this example can be for the random variable, x equals score when a fair dice is rolled. So we can see in an example table over here, we have x, 1, 2, 3, 4, 5, 6, which is basically the sides on the dice that you will get, and p equals x equals 1 over 6. So that means that the probability of getting 1, 2, 3, 4, 5, 6 is only 1 to 6 because the numbers are only once on one side of a dice. So the letter X represents the event we are considering and includes all the possible outcomes. And the lower row means the probability of an observation being equal to X. So in this case, the probability of the score when a fair dice is rolled being equal to X. Right. So if all the probabilities are the same, it is known as a discrete uniform distribution. Okay, so now we're going to be talking about binomial distribution. So to use the binomial distribution, a number of conditions must be met. So the first condition is that there are a fixed number of trials. Number 2 is that there are 2 possible outcomes, so you can think of them as a success or failure. And lastly, the probability of success is the same each time. And the trials are independent of each other, so the outcome of one trial does not affect the next trial. So, if x is bn, p, then this will be the formula. So So if x is binomially distributed, then with a number of trials n and a probability of success. Guys, so we are going to be starting off with some questions. So I'm going to be doing 2 questions, but they are going to be quite a bit of work, but I'm going to be giving you guys a bit of time so you'll be able to finish up these questions, and once you're done answering, you can just keep on watching and continuing on to the video. So without further ado, let's get started with the questions. So I'm going to be displaying these questions on screen right now, but this is question number 1. Xavier, Yuri, and Zara attend a sports center for their judo club's practice session. The probabilities of them arriving late are independently 0.3, 0.4, and 0.2 respectively. Calculate the probability that for a particular practice session, 1 or I, all 3 arrive late. I, none of the 3 arrives late, and I, only Zara arrives late. So first of all, I'm going to be writing down just the numbers that they have. So we're going to do 2, pen, okay, 2, I. So first of all, I'm just going to be writing down the values that they have in the top corner, just so I remember. X is 0.3, and then Y is 0.4, and then Z is 0.2. These are just their names, by the way, their first letter names. Anyway, so now that we remember them, we are going to start off with I. So the first question is all 3 arrive late. So all we need to do is we need to times them all together, because if we were going to say that all 3 arrive late, it would be X subset Y subset Z. So that means that all of this would happen at the same time and all of them would overlap at the same time. So all we need to do is write 0.3 times 0.4 times 0.2. And when we add those together, the value that we will get is 0.024. Very simple. That is our first answer. So for number 2. So the next question is none of the 3 arrive late. So if it's none of the 3 arrive late, what we're going to do is we're going to subtract 1 from the values of 0.3, 0.4, and 0.2. So that will give us 0.7, 0.6, and 0.8. So once we get those values, all we need to do now is we need to multiply them together. So, like I said before, it is 0.7 times 0.6 times 0.8. And if we get that number, we are going to total that into 0.336. Done. So now let's move on to question number 3, or I. So the last question is only Zara arrives late. So if we're going to only put Zara is late, that means that would mean that Xavier and Yuri are on time. So all we need to do is we need to put the values 0.7 times 0.6. That's what we calculated before by subtracting the late number times 0.2 because Zara is late, and from that we get 0.084. There we go. Relatively simple question. So now let's move on to B. Zara's friend Wei also attends the club's practice sessions. The probability that Wei arrives late is 0.9 when Zara arrives late, and is 0.25 when Zara does not arrive late. So the question is, calculate the probability that for a particular practice session, both Zara and Wei arrive late. So for this question, what we need to do is we need to figure out what happens if both Zara and Wei arrive late. Sorry, that was a bit of a handful to read. So that would mean that would be Z subset W, because they overlap at the same time, and that means that happens at the same time. So what we need to do is we just need to multiply 0.9 times 0.2. We basically got 0.2 from what the question itself. So if we have 0.9 times 0.2, our answer will be 0.18. Easy. Next, for question 2, either Zara or Wei, but not both, arrive late. So that means that, one or the other is late. So that would mean that it could either be P equals Z W or union Z dash W. Okay. Sorry, that isn't writing wood too well, but you get the main idea. So that would mean 1 minus P Z W U Z W. That's basically what it would mean. So what we need to write down is equal to 0.2 times 1 minus 0.9 plus 1 minus 0.2 times 0.25. So all we're doing is just, adding the numbers that we have been given and just putting them into a formula that we've created. So that would mean if we calculate that, all those numbers together, that would give us 0.02 plus 0.20, which makes it 0.22. So that would be our value. And that's it for the first question. So let's now move on to the second question. So up for the second question, the British and Irish Lions 2005 rugby squad contained 50 players. The nationalities and playing positions of these players are shown in the table. So the table will be displayed as of now. A player was selected at random from the squad for a radio interview. Calculate the probability that the player was 1. A Welsh back, 2. English, 3. Not English, 4. Irish given that the player was a back, and 5. A forward given the player was not Scottish. So let's start with AI. AI. So if the Welsh is a back, so we can just see from the table basically that this would mean that if the Welsh was a back, it would be 7 over 50, because that's the total of all the values in the table, and that would make it 0.14. That's a very simple question and very easy to understand and digest. So for number 2, English, simple. We look at the table and we can see the values. So it would be 14 plus 8 divided by 50. And that would make it 11 over 25. And you can write it in decimal points as 0.44 if you'd like. Right. 3. We have not English. So basically, as long as they're not English, you just need to add all the values together and that will be fine. So it would be 1 minus 11 over 25 equals to 14 over 25, sorry. So why did I use 1 minus 11 over 25? Well, basically we were already calculating the people, the players who were English, so all we need to do now is just subtract that with like the total amount of players, and that just makes it so much easier to calculate. But if you want to do it in another way, that's obviously fine as well, but just try to make shortcuts. It'll also be quite easier for you to do as well. So that's what I did, and that's the answer, 14 over 25. Now let's move on to the fourth. Irish, given that the player was a back. So all we need to do is just add all the values together. Obviously that will be the backs. So it will be 8 plus 7 plus 2 plus 6, which will be 23. Oh, sorry, I didn't write that down. That will be over 23. And they need to be Irish. So it will be 6. 6 over 23. And for number 5, a forward, given that the player was not Scottish. So all we need to do is just add all the forward players, so Welsh, English, and Irish, but just don't add the Scottish. So that would be 14 plus 5 plus 6 over 50 minus 4, which would be 25 over 46. Great. Now for our very last question. 4 players were selected at random from the squad to visit a school. Calculate the probability that all 4 players were English. So that would mean that it would be 22 over 50 times 21 over 49 times 20 over 48 times 19 over 47. Oops, sorry. Okay. So the reason why the numbers are decreasing one by one is because we are, selecting a player each time. So that means that the total amount of players does decrease. So once we do that, that means that the numbers of players decreases, and also the number of English players also decrease as well, because we're picking 4 English players in a row. So that would turn into, if we calculate it, 209 over 6580. And that will be your answer. So that is all that I have for you guys. The practice questions were pretty easy to do and pretty fun to do. So I really hope you guys like this video, and I hope it is quite helpful and you guys get like a good understanding of the subject, or to like at least have a good refreshment of what you have learned from IGCSE. It's not very much different. It pretty much is very similar. All you need to do is just polish your understandings and be more focused in the topic, and it will be all good for you. So I really hope you guys like this video, and I hope you enjoyed, and I hope to see you guys next time. Bye bye.
This has been the 4 Mathsketeers. Don't forget to like, share, subscribe, and turn on notifications for